So we've gone over all these before, but I still have found that some of you need a little more support and help with solving equations and solving inequalities. So I'm going to try approaching it with a different method. I don't mean it's a new method to learn it or to solve it. I'm just saying kind of a creative approach that might help you understand how and why we're using the methods we use to solve it. Now I'm going to do this the way I did in my classroom. We're going to have two voices explaining things to you. So I often joke that the true math geniuses in the world, the politicians don't trust them because they know if they let them roam free, those mathematical geniuses will just take over the world. So they have prevented this from happening by locking those math geniuses in a tower far, far away and requiring them to write math textbooks. So what I'm going to do is show you how a math textbook writer, an evil math genius locked away into a tower, creates the problems we have to solve, and then show you how we can use that to help us understand how we solve the problem that they created. Let us begin. Hello, my name is Jacques. I am an evil math genius. Well, at least a math genius. People think I'm evil just because I like math. But my job is to write textbooks. So, well, the students don't know it. I actually begin making problems by starting with the answer. So I choose x equals -2 as the answer to the first question. Then I say, how will I fool these little mathematicians into not knowing what x is equal to? And I say, one thing I could do to disguise it. I could add a number to both sides. So, what number should I add? I choose 5. So I'm going to add 5 to both sides. Yes, very good. So, x plus 5, no like terms there, so we just have to write x plus 5. -2 plus 5 are constants, so they are like terms. -2 plus 5 is 3. But then, I hide my work. I hide the answer, and I only write this part in the math textbook, and they have to figure out the answer. Well, okay, so I did one by adding to both sides. Now let's do one by subtracting from both sides. I think I use a 2-digit number. They hate those. So x minus 11, no like terms. We just write x minus 11. 3 minus 11 is -8. Then I do my dastardly deed, and I hide that part so they don't know what the answer is or how I made the question. Instead, they have to solve this equation. All right, thanks, Jacques. So we see how Jacques created the problems. But again, you'll be seeing just the equation, just the problem. So I want to point out to you that to solve the problem and get the answer, we simply have to undo what he did to create the problem. Here's what I mean. He started with the answer, and then he added 5 to both sides. If we want to find the answer from the question, we'll have to do the opposite of what he did. We will subtract 5 from both sides. 5 minus 5 is 0. X plus 0 is x. 3 minus 5 is -2. Now I understand some of you look at this and be like, well, wait, we just came right back where we started. I know it looks like that here, but again, what you'll be given on homework, quizzes, and tests will start here. You won't know the answer. I'm showing you all of this, so I hope you can see the parallels or the pattern or the rhythm. That's not quite the word I want, but the steps we take to go from creating a problem to solving a problem. Now this is often true even with things that aren't math. The way to solve a problem is to undo what created the problem. If people don't clean up the dishes off their lunch table, that's a problem. And the way you fix that problem is you force them to clean up the dishes from their lunch table. So you go from not cleaning up to cleaning up, and it fixes the problem. Okay, now let's look over here. This time, he subtracted 11 from both sides. So if we want to undo what he did, we have to do the opposite of what he did and add 11 to both sides. And that shows we did the right thing because we got what we know is the correct answer. My work did not confuse them enough. Okay, so I cannot simply add and subtract. Perhaps this time we will multiply and divide. Yes. Oh, and I know what I'll do. They hate negative numbers. I'm going to multiply both sides by a negative number. Negative 5 times y, negative 5y. 6 times negative 5 is negative 30. Good. We have the problem. But of course, I will hide this so they only see the problem. Now number 4, we'll try, let's see, dividing. Yes, I believe I will divide by 7. W divided by 7, we will just leave that as a fraction. Negative 7 divided by 7 is negative 1. Very good. So now we have 2 questions where they will have to multiply and divide. We'll see how they handle this. Okay. Now, please remember, you won't be seeing this on what I'm covering up. This is not going to be seen on a test or quiz. This is what you'll see. So what I'm trying to help you understand is why we always do the opposite of what they did. So let me word it this way. In order to create this math problem, Jacques multiplied the variable by negative 5. Our goal is to get the variable by itself, to isolate it. So what he did to it, multiplying it by negative 5, we have to undo it by doing the opposite. So he multiplied by negative 5. We need to do the opposite and divide by negative 5. Negative 5 divided by negative 5 is 1, so we have 1y. Negative 30 divided by negative 5 is positive 6. So we get right back where he started. Because what Jacques does by creating the equation, he goes from having a variable that is alone and isolated to one that is not. So to get it back by itself, we have to undo what he did by doing the opposite. So same idea over here. The w was by itself, but then he divided both sides by 7. So that tagged the 7 on with the w. So we've got to do the opposite and multiply both sides by 7. So I'm just writing this over here to note we're doing the opposite. He divided by 7, we multiply by 7. So the 7's over here cancel, because 7 divided by 7 is 1. Negative 1 times 7 is negative 7. Oh, those dastardly kids, more like it. Oh. Okay, so if doing just one step won't confuse them, perhaps I will do 2. Yes, okay. So, here's what I will do first. This time, I will start by multiplying. So I will multiply both sides here by 2. 2 times h is 2h. Negative 4 times 2 is negative 8. But we need to add another step. Yes. I will add 6 to both sides. 2h plus 6. And negative 8 plus 6 is negative 2. Okay, let's do something similar over here. This time all is multiplied by negative. They love it. I will multiply by negative 7. Both sides. That gives me negative 7k equals positive 21. Because they better remember, a negative times a negative is a positive. Okay, but then I will subtract. Well, let's subtract 18 from both sides. So I get negative 7k minus 18. 21 minus 18 is 3. Yes, this will foil their plans. because once I cover up my masterful work in creating the problem, they will have a more difficult time solving these problems. Okay, let's see if we can undo what Jacques has done. So I think this might even be more helpful with the two-step equations for you to see how what created the problem, we just do the opposite to solve the problem. So the first thing he did was he multiplied by 2. The second thing he did was he added 6. So we need to do the opposite, but we need to consider the order. So we're trying to work backwards. So as he started up here and moved down here. We're essentially trying to start here and move back up this way. So as we cross back up, the last thing he did, was add 6. So that means the first thing we should do is subtract 6 from both sides. So 6 minus 6 is 0. 2h plus 0 is 2h. Negative 2 minus 6 is negative 8. So we subtracted 6. Now, the first thing he did when he was changing things up was multiply by 2. We want to do the opposite and divide by 2. So we'll divide both sides by 2. We get h equals negative 4. Oh, sorry. We divided by 2. So I want you to see kind of how it's almost a mirror image here, kind of a reverse parallel, so to speak. Because the inner things, his last thing was our first thing. His first thing was our last thing. But you can still see how we did the opposite operations in the opposite order. He multiplied, then added. So to undo his treachery, we subtracted, then divided. It'll be very similar over here on this one. The first thing he did was he multiplied by negative 7. The second thing he did was subtracted 18. So we'll want to go in the opposite order and do the opposite thing to fix this. Since the last thing he did to mess with the k was subtract 18, that means the first thing we'll need to do is to add 18. So that negative 18 plus 18 is 0. 7k minus 0 is 7k. 3 plus 18 is 21. So we added 18. See the parallel right there. Now he multiplied by negative 7, which you can see right here, it's negative 7 times k. So we've got to do the opposite and divide by negative 7. And we get the answer he started with. And again, you can see the parallel. We divided by negative 7. So it parallels with what he did first. Ah, they figured it out. Oh. Okay, so last time I multiplied, then added or subtracted. This time, what's that? Oh, yes. They hate fractions. So I will first divide. Yes. Very good. Okay. I'm going to divide both sides by 4. So x over 4 becomes a fraction, which they love. Then 20 divided by 4 is a 5. That's one step. I divided by 4. What's my next step? Let's do minus 9. So I will subtract 9 from both sides. Now the x over 4 and the 9 are not like terms, so they cannot be combined. We will do x over 4 minus 9. 5 minus 9 is negative 4. So I divided by 4 and then I subtracted 9. We will do something similar over here. Yes. Let's divide by 11. Let's divide by negative 11. So first thing is to divide by negative 11. We get b over negative 11. Negative 11 divided by negative 11 is 1. And then I will add 17 to both sides. So add 17 to this side and to this side. These are not like terms. They cannot be combined. I'm going to add 17 here. 1 plus 17 is 18. Yes, surely with these fractions it will freak them out because I will hide my wise work. Okay, it's still a two-step equation, like it was last time, but this time he did divide first. So again, he divided by 4 and then subtracted 9. So we'll do the opposite in the opposite order. Since the last thing he did was subtract 9, we'll add 9 to both sides. Negative 9 plus 9 is 0. X over 4 minus 0 is x over 4. Negative 4 plus 9 is 5. So we've got these two linked. Subtract 9, add 9. Now we'll need to multiply by 4 because as you look, what's still with x is it's being divided by 4. So we need to do the opposite and multiply by 4. So I multiply this side by 4, multiply this side by 4. This is really 4 divided by 4, so that's 1x. 5 times 4 is 20. And we've gotten the answer he got. Okay. He divided by negative 11, then added 17. So Wolf, we need to first get rid of the 17 by subtracting it from both sides. So this 17 minus 17 is 0. B over negative 11 plus 0 is just itself. 18 minus 17 is 1. So we've got this covered. Now, he divided by negative 11. We want to do the opposite of that and multiply both sides by negative 11. So negative 11 over 1. So the negative 11 over negative 11 cancels out because that's equal to 1. So we have 1b is equal to, this is just the operation right here, paralleling that. 1 times negative 11 is negative 11. Farfanugan. Oh, I only have one other trick I can use this time. Then I'll have to go back and plot for different tricks. Oof. Okay. This time, fractions again. Yes, but this time I will make it a very big fraction. Okay, so I think I will start this time by adding, let's add 10, why not? G plus 10, and negative 10 plus 10 is 0. But now I make giant fraction because I'm going to divide both sides by, let's do 8. So I divide both sides by 8. So G plus 10 over 8 equals 0. Because 0 divided by 8 is 0. Okay, good. Over here, let's subtract 22. Subtract 22 from both sides. X minus 22. 8 minus 22 is negative 14. Let's divide both sides by 2. So this we cannot reduce, we leave it as it is, x minus 22 over 2. This we can reduce, negative 14 over 2 is negative 7. So we will see if this new plan helps. I added 10, then divided by 8. I subtracted 22, then I divided by 2. Alright, let those little want-to-be mathematicians try their best. Okay, these were our last ones for this section. So this is one I know you guys didn't like a lot when it was a big fraction. So you got to work backwards. He added 10, then divided by 8. So we've got to do this 8 issue first. We need to multiply both sides by 8 to start our game. So we multiply this side by 8, multiply this side by 8. This really is 8 over 8, so they cancel out because 8 over 8 is equal to 1. 0 times 8 is 0. So we took care of the 8 by doing the opposite of what he did. Now, G still has 10 added to it, which is what he did first, so we need to do the opposite and subtract 10 from both sides. 10 minus 10 is 0. 0 minus 10 is negative 10. Okay, here he first subtracted 22, then divided by 2. So we need to do the opposite of that. We need to start by multiplying by 2. Here, the 2's cancel. 2 divided by 2 is 1. Negative 7 times 2 is negative 14. So we still have x being subtracted by 22, which is the first thing he did. So to undo that, we'll need to add 22 to both sides. So these two cancel out, these two cancel out, and negative 14 plus 22 is 8. Okay, good job. We'll see what dastardly things he comes up with next time. And here are two things that are good to remember. Solving an equation requires getting the variable isolated, meaning getting it by itself. And whatever you do to one side of the equation, you must do the same to the other side of the equation.